All right, so this was part 3 for chapter 3. And this one has to do more with how do we use systems of equations to solve word problems. And a big part of this chapter is the word problems. So with word problems, a lot of times I'm going to be saying to you, we got to look at two things. We got to look at the numbers that we're talking about and the money that we're going to be talking about. So we're going to want two equations. One is going to have to do with numbers. One is going to have to be money. So play was attended by 342 people. Some people were adults and some people were children. So I'm going to have the adults be an A and the children be a C. And so the adults plus the children add up to 342 people. All right, so that's my number equation. Money. Well, for every adult, we're going to charge $1.50. So $1.50 times the adults. So if there's 10 adults, it's $15. If there's 20 adults, it's $30. The children only are charged 75 cents. So every child per child is 75 cents. So again, 10 children is $7.50. 20 is $15. Now, once they did all that, and we don't know how many adults and how many children there were, but in the end, we knew we got a sum of money of $369. All right. So what we know is $1.50 for the adults and 75 cents times every child equaled $369 in the end. So we have a system of equations here. We have two equations. We could either use substitution or elimination. And honestly, I don't know if I have a preference of substitution or elimination. I think for me, I look at this and I say, well, you know what? If I have the adults plus the children equal 342, then the adults must equal 342 minus the children. Okay, so in other words, I just took and I subtracted a C from both sides of my equation here is what I did. So if I know that the adults are really this amount, I can put instead of this adult amount, I can say really we have 342 minus C. And we have $1.50 here, okay? So let me explain what I just did here. What I did is I took the 1.5 times the 342, I got 513. 1.5 times negative C was the negative 1.5 C. Then I had the plus 0.75 and equaled 369. I combined like terms, I combined these two terms here, sorry, and that would equal to negative 0.75 C. Then I subtracted the 513 from both sides. That's how I got negative 144 over here. I had negative 1.75 here. Divided both sides by 0.75, and then I found that the children must equal 192. Well, if there's 192 children, then the adults would equal 342 minus the 192. The adults must be 150. So what we found is that there's 150 adults and there's 192 children. And then we have to see, did we answer our question? How many children attended the play and how many adults? We did answer the question. All right, next problem. Let me move this down here a little bit. Oh, they're combined, sorry. All right, a new problem. Sarah goes to the store and she's buying notebooks and pencils. Boxes of notebooks and boxes of pencils. I'm going to make notebooks N and pencils P. The notebooks cost $1 each and the pencils cost $1.50. She leaves when she has 23 items and she has a total cost. So again, we have number and we have cost. The number, the notebooks plus the pencil, the boxes of pencils was 23 total items. The cost, for every notebook, it's $1 each for a notebook, and for the pencils, it's $1.50 for the pencils, and we spent $27.50. Okay, now I'm going to do this one a little bit differently, and then I'm going to say, you know what, let's just change this one so it's elimination. So I'm going to modify this second equation, and I'm going to multiply everything by a -1. Okay, when I multiply everything by a -1, what I get is I get -1n negative p equals -23. Now I'm going to just copy this one down. Really here I have really 1n and then plus 1.5p equals 2750. Now if I added these together, I have a 0 here under my n column, 1p a negative 1p, and a positive 1.5 gives me a 0.5p. All right, 27, I'm going to do it on my calculator here, $27.50 minus $23 gives me $4.50. Then when I divide both sides by 0.5, I get that the p's equal 9. So there are 9 pencils. Well, in the original, the pencils and the notebooks have to equal 23. If there's 9, the notebooks had to have been 13, 14, 14. All right, so what we found is 14 notebooks and 9 pencils. That was our solution there. Okay. Now, let's go back through here. Sorry about that. All right, so now we're going to go through another one. The school that Lisa goes to is selling tickets to a talent show on the first day. Now, this one's a little differently. There's 4 senior tickets and 5 student tickets for a total of 102. Now, it's not a number because they don't ever say they sold this many total tickets. But what they do is what we have here is we're given information about 2 different days. Day 1 and day 2. And it's kind of like we're given money for day 1 and money for day 2. Okay, so on day 1 we have 4 and we have students. We're going to have here, we have senior citizens and students. So we're going to call senior citizens X and student tickets Y. So there was 5 student tickets, 5 Ys, and that was $102 that we made. On day 2, on the second day, we took in $126, and there were 7 seniors, that was our X, and 5 student tickets, that was our Y. Okay, now I think the way to go on this is really elimination. And I'm going to do it right here. I'm going to change my whole first equation. I'm going to just change the sign of each and every term. So what I basically did is I multiplied everything by a negative 1. By doing that, and then I can add them, I get that 3x plus 0 equals 24. All right, well, if 3x equals 24, x equals 8. We know there were 8 senior citizen tickets. Well, if x equals 8, and I can kind of go from, it doesn't matter which, here I'm going to go to this one. There were 7 times the number of senior citizen tickets, 7 times 8, plus 5 times y equaled 126. All right, 7 times 8 is 56. 5y equals 126. Subtract 56 from both sides, 70, and divide both sides by 5, 116. All right, so there was, now we know there was 8 senior tickets and 16 student tickets. So that gives you, and word problems, you just got to do more and more and more, and that's the best advice I can give you, is that you just have to keep working at word problems to get good at them.